What if you're able to predict the box office success based on the Twitter trends in a geospatial context? Look at this IBM demo right now.
Hi, I'm Torsten Steinbach. I work for IBM Cloud Data Services, and I'm lead architect for dashDB, which is one of our cloud data services that we are presenting here today. dashDB is one of our cloud data services that we are presenting here in combination with a second one, which is Cloudant, because actually the power of these two together is actually one of the things that we really want to showcase here. So those are two databases in the cloud. Cloudant is really a JSON document store, which is ideal for mobile applications, for IoT applications that generate data basically in the cloud, data that originates in the cloud from these applications. And this data very typically has a geospatial property, like where basically the data is coming from. Now, this is very interesting for us with dashDB, because dashDB is actually a place where you can put all kinds of data to analyze it, for instance, geospatially, but not only. So one of the things that we are doing is to combine dashDB and Cloudant in a very tight manner. So you can build your mobile applications, let it store its data in Cloudant, and leverage the integration feature between those two to basically automatically discover what is the schema, what is the geospatial data in these JSON documents, and generate geospatial data types in dashDB automatically, and have an ongoing replication between both two going on. So that basically you pretty much for free automatically get the ability to analyze all your data that comes from mobile applications. One of the things that we are showing you here is a showcase about insurance, where we basically have set up dashDB as a cloud data warehouse to pull data together from various sources. One source is your traditional on-premise system, where you have your system of record data, like your customer contracts, right? These are insurance contracts about their property, what's the insured value, where do these customers live, what's the address, and so on. The next thing that we are pulling in here is data from the field, from mobile applications, where, for instance, the insurance agent or even the customer himself, for instance, files claims and just takes a picture and submits this whole thing via this mobile application. So this is the thing that lands in Cloudant, and that we are also pulling together via this tight integration into dashDB. The third thing that we're pulling together is, I would say, reference data, geospatial reference data. So one thing is just administration data like polygons, like the county boundaries that you see here. But also, in this case, because we're talking about insurance, they need to know about weather conditions. So in order to see what's the risk for insured property, might there be a fraud, and so on. So we are also putting in this case here, tornado data from noaa.org, which is just another set of data that you pull in. And so if you just visualize the raw data, it will look something like this. You see all these tornado tracks that come in. Now, the point is, we talk about really hundreds of thousands of records from customers and hundreds of thousands of tornadoes, and a lot of thousands customer claims that are coming in. So in order to analyze all that, it is a scalability issue if you have to pull out all this data to analyze it in a tool outside of the database. For this reason, we have built into dashDB a set of geospatial operators so they can push down these analytics. So for instance, in the case of the tornadoes here, the first thing that you can do is, let's just analyze, or let's just sum up the actual risk based on the history of tornadoes over the last 50 years by US county, so that we can get a heat map on the actual tornado risk by county over the US, across the US. And this is something we are doing, this happens live here with all the tornado records that we have stored in the database, and then we can generate this map with that. So this happens all in the database, and we just use the S3 tooling for presenting and visualizing the result. We can go further. We can now pull in a third data set here to say, okay, it's good to know what is the actual risk that a tornado occurs in a certain county, but how is it financially for me as an insurance company? So we pull in also the insured value that we aggregate up in the same county boundaries, and to get a much more focused picture on what are the counties that need maybe special attention in order to prevent damage, because there's an increased likelihood of tornado to occur, and there's a high value of insured property within this county. So this is all basically for me to do planning as an insurance company and calculation of the insurance rates for my customers. And it's all happening on big data, on large volumes of data. Now, the next thing I can do, I can also take more data from real time. Like, for instance, if a customer really files a claim, let's look at these claim records and see whether basically I might be able to prevent the damage by whether we might have a fraud and the claim is coming in. So in this case here, we basically have all the claims in a certain period of time that have occurred that we are observing here. Let's overlay this with weather warnings that we are also basically pulling in along with all the historical weather data. We permanently pull in weather warnings from Noaa.org in this showcase. And by having both together, it's just yet another small map that we can generate to flag those that are potential frauds. Because those are claims that were filed for a time in an area when there was no tornado warning going on. And finally, we can also go further and say, okay, let's prevent damage. Because we can look at weather warnings that are ongoing right now. So we see we have currently here some warnings going on in this area. We can zoom in. So these are really weather warnings that are sort of ongoing right now. And we can again combine this information with our insured value in this area. So in order to say which of these weather warnings is important for me because I have a lot of insured value in this area. And this is here in this case, this one. And then we can say basically, okay, show me my customers that I do have in this area. So I can call them, I can page them, I can alert them to protect the property, and this is for mutual benefit. I mean, the point about all this is we have pulled in data from mobile applications through Cloudant, we have pulled in traditional data from on-premise, and we have pulled in data that is publicly available from Noaa.org into the same place, and it was just a matter of setting up some maps with Esri that basically leverage in-database analytics operators to visualize the result. So all of that is a matter of a few hours basically to get going. So here's another little showcase that we have done that highlights a little bit the power of dashDB from a geospatial analytics side, but also from its capability to easily digest data from various sources. So what we have done here is a little application in Bluemix, which is IBM's platform cloud service where you can build your own applications and leverage services like dashDB in an end-to-end manner. And this application basically does two things. It loads data from Twitter, which is just yet another Bluemix service that you can consume to load data from it, eventually they come from Twitter, for a certain movie. In this case, we have done American Sniper, so we did it at the time, the beginning of this year when this whole thing was hot and the Oscar time was. And from the same period of time, we also took data from the numbers.com, which is a public website where you can get general box office numbers every week and every day. So, and what we have done with that is basically we're looking at the trend over time of the box office numbers, which is the blue line, and at the same period of time, the tweet volume about the movie American Sniper. So it's about 1 month worth of data here at the beginning of the year. And you can see, yes, there are these bumps, which are the weekends for the box office, obviously. But overall, the trends are pretty comparable. So the decline rate of the tweet volume about the movie is pretty much the same like the box office success, the actual box office success over time. So with that information, we can now use tweet data about a movie in order to predict box office success. And what it one advantage that this is because tweet data, we do have the ability to cluster it by region. So we geospatially group it, in this case just simply by US state, to say, okay, this is the tweet volume trend by US state over these 4 weeks. And we can highlight those US states where the trend is declining more rapidly than an average, which means that probably also the box office success will be lower than an average from a trend perspective, which allows me as a promoter of this movie to do much more focused campaigns in these states than to do a broadband campaign to support the box office success of the movie in the days to come.